one. Let me get this thing. Okay, Eric, how has flash memory disrupted the telco storage market?
Well, for us, it's been very disruptive. 5 of the 10 largest telcos in the world use Violin technology in production in telco-specific use cases. So let's take the 2 major use cases. By the way, we also help the telcos in very traditional IT infrastructure use cases that work with other companies in financial, in healthcare, and other areas, but let's be very telco-focused. So the first one is high-performance billing systems. So these billing systems are very sensitive. So for example, one of our customers in Europe, again, one of the largest in the world, minutes went up, billings did not. What they found out was the software they were using, which was an Oracle rack configuration to help track this billing, needed to be rewritten. They did that. They tried it on traditional storage based on traditional hard drives. We sell technologies based on using all flash. Did not work on the all hard drive system. They were using us in some virtual environments in generic IT. Tried us in a specific billing application, worked right away. For them, they're going to bill an additional $140 million a year on less than a $2 million investment in our hardware, and obviously with a 3-year lifespan, they're going to bill almost $500 million on an investment of only $2 million. Second use case is real-time network and satellite monitoring. So in this case, you've got a lot of data points that are coming off of the systems in the field, and you need to make sure what's working, what's not working, how to route signals around, what do you got to do. If it's a tower problem, literally get a guy out to fix the tower. If it's physical, and obviously if it's software, to adjust the software problem on the tower. So we have several companies in the world that use us for these real-time systems. Again, they had to rewrite their software to take advantage of all these data points. In this case, it'll be an example of what you may have heard of referred to as big data, gobs of data coming in, if you will, the Internet of Things, gathering all these data points. These systems are very, very sensitive to performance applications and very sensitive to the overall performance of the underlying physical infrastructure, their servers, their networks, and their storage. In this case, I'm thinking on the IT side, and we fix that. And so we've got the first use case, which is several telcos using us in real-time billing systems to capture all the appropriate dollar value of those minutes. And the second use case is literally real-time monitoring of their physical infrastructure to make sure that everything is working and make adjustments, reroute, fix hardware, fix software, physically repair towers and other aspects. So those are the 2 big use cases in generic telco that are very specific to the telco industry.
So how does it work?
Well, very straightforward. The key thing here is your servers are actually dramatically faster than your storage. Okay? And this is referred to as the I/O gap. So what the IT guys do in any industry, telco being no exception, in order to make up for this big I/O gap, they literally buy more servers and over-provision those servers. Okay? So what flash does, it's a much faster form of storage. It gives you much better physical density of space. It allows you to shrink what's called the rack and stack, and obviously many people in the telco understand that with all of the gear they need. So it shrinks the rack and stack, but most importantly, it has a flow through in this server infrastructure. So an example is we had a customer, they had 48 physical servers. The application had to be the SQL database. By putting the Violin flash array in there and taking their regular storage out, they were to go from 46 physical servers to 2, doing the exact same workload. So that's an example of how flash works. It shortens this gap between servers, which are much faster than traditional storage. Flash bridges that gap, allowing you to shrink the number of physical servers that you have to use and deploy, regardless of your application in your telco environment.
So at the physical level, when you look at a read-write disk versus flash, I mean, at the technical level, what's really happening on the flash storage device?
Sure. So the difference is with flash, you use semiconductor technology. You may have heard, even in your home computer, DRAM, which is the fastest form of direct memory access using semiconductors. Flash is the second fastest, substantially faster than disk drives. So what happens with your disk drive subsystem, trying to get the performance you need for your real-world applications, what they do is they take the disk drive, which actually looks like a DVD, and basically on the outer edge is how a disk drive is faster. So what a disk drive company like an EMC or an HP will do is take a bunch of these, stick them in a big system, and what they do is on each one of these physical devices only use the outside of it. So that gets better performance. Not near enough performance to solve this gap. but it gets better performance. The problem with that is you end up paying for the entire disk drive even though you only use part of it. With flash, you don't have to do this. Technology is called short stroking in the disk drive industry. You don't have to do that with flash. You basically get to use the entire piece of memory that's available. You have a much faster performance when you use flash storage versus traditional storage. This, in fact, as I mentioned in the billing use case, the telcos tried this traditional approach and it didn't work. They'd rewritten their software. No matter what they did, they could not make it work on this approach. But when they went to flash, it worked right away. So that's a real-world example of the difference from how the technical difference solved a real-world business problem, in this case, a billing problem.